Welcome to our computer science lesson today. Today we'll start with the first chapter of computer science in the IGCSE 0478. So our first chapter is data representation. Now, in this video, I'll tackle part one, where we'll tackle number systems and number conversation. Then in the next video, we'll tackle part 2, which is binary calculations and uses of hexadecimal. Then the third video will be part 3, which will be text, sound, and images. Then we'll also tackle the measurement of the size of computer memories. Then the last video for this series will be part 4, which is the file types. Now we can start. Now, in this video, we'll start with the number systems. We will go through the binary system, denary system, hexadecimal system. After that, then we will also go through the number conversions, which will convert from binary to denary. We'll also convert from denary to binary, then from hexadecimal to binary, then from binary to hexadecimal, then hexadecimal to denary. Then the last we'll tackle is denary to hexadecimal. So, what is base? We all know that all number systems, they have a base. And a base is how many unique digits are available before you have to carry over to the next column. So for base 10, which is denary, this is normally the human number system, the one we're used to 1 to 9, 0 to 9. So it has 10 digits. So it has base 10 because it has 10 unique digits. For binary, it has 2 unique digits. So it's base 2. Then for hexadecimal, it has 16 unique digits. Now that one is base 16. Now later on we'll understand better how the 16 or base 2, base 10, especially when we'll be dealing with conversion. Now, binary is it's actually the language of computers. Since computers communicate more using, actually they use only binary. So in binary, these are zeros and one. So they use zeros and one because it's easy for electric circuits to communicate, because the components in the computer are just made of circuits, so if it's on, which is 1, off, 0, so it makes it easy to communicate. So why is it important? The two main reasons. One is because of simplicity and reliability. So it is very easy to build hardware that can reliably distinguish between two states: high voltage, low voltage, magnetized versus unmagnetized. Then imagine if computers would understand 10 different states. It would be too much work for even the builders. Yeah. So that's why, for simplicity, 0 and 1 would be the best, because also it's a machine, so easy to even to design. Yes. So the first reason we've seen it's simplicity and reliability. Now the second, it's because of the logic. The computer logic decision, they're also true or false, just like Boolean. So because of the computer logic, it helps with decision making. So it's very easy to make decisions. Yes. So also here, this is just a recap of what we learned earlier. A base. So we know that a base is the unique digits that are in a number system. So this will We'll explain more as we do the conversion part. So at least I think now the binary is well understood. This is the language of computers. Basically, it contains zeros and ones. So the next one is the hexadecimal. So this is where people often get confused because we say it's hexadecimal is in base 16, right? But it starts from 0 to 9, right? So these are already 10. So from 9, in binary, the next would be 10, but for hexadecimal, the next is A, then B, then C, D, E, F, up to 15. So that's how the number system. And it's needed because sometimes the humans, we can't really, the binary is too long for us to remember. That's why now they introduced also hexadecimal, which is easy for human beings to represent. Yeah. Then now we'll tackle the number conversion. Now the first conversion we want to take is from binary to denary. So the first step is we are being told is we need to place the binary value. That's the first step. Place the binary value in columns of 2 raised to the power of the number of values from the right, starting from 0. Okay, we're going to explain that. For binary value 110000011110. So the first part, basically what it says is we need to put them in a column, right? So the first column, we need to raise it to starting from 0, right? To starting from 0. So this 2, we started with 2 raised to power 0 is 1. 2 raised to 1 is 2. 2 raised to 2 is 4. So we continue like that up to the end. Can even go to 2 raised to 10, yeah. But for the sake of our example, it's 2 raised to 7, which is 128. So what we do is, then we go to the next. So once we get the results, we start naming them 1, 2, 4, 8, 16, 32, 64, 128. I think you've already seen the pattern because it's just 2 raised to 3, 4, 5. Yeah. So with time, we'll get used to it because it will also help us to convert the other types of number system. So in our case here, we'll put this 110 into the column. Then we'll start now. Where there is a 1, we'll add them together. This one. So once we are done, let me circle the ones. These are the ones, right? Yes, these are the ones. So we have to add them up. So we'll say 128 plus 64 plus 32 plus 8 plus 4 plus 2, and we'll get it to 38. So this is the easiest way to convert from binary to denary. Now we can go for another example. Since now we already know we have to put them into column, our first step is just to start from 1, 2, 4, 8, 16, 32, 64. Then we put it corresponding to this. So instead 0, 1, 0, 0, 0, 1. Then remember the next step is we get the ones where there is 1, then we add them up. So this is 64 plus 2, 66. So with that, I'm sure we're good with that. Now the next is converting denary to binary. Converting denary to binary. So the first step, it tells us that take the value and success take the values and successively divide it by 2, creating a table like this. Yes, we'll discuss this. Then the next step is when converting a decimal number to binary, you repeatedly divide by 2. Yes. If the number you're dividing is odd, we know odd numbers now, right? Yes, numbers that are not divisible by 2. So if we are dividing by an odd number, there will be a remainder. So the remainder will be 1. And if it's an even, the remainder will be 0. Okay. Then the last part, which is the most important part also, is the binary number is found by reading the remainders from the last step. This is very important, from the last step to the first step. Okay. So let's follow our steps with an example. So let's convert this 156 from binary to binary. Now, we are being told we need to divide successively by 2. Yes, now we start. 2 divided by 156, we get 78, right? Like this, we get 78. Is there any remainder? No. Put 0 here. Then we go to the next. 2 divided by 78, we get 39. Any remainder? No. Put 0 here. 2 divided by 39, we get 19. Yes. Is there any remainder? Yes. 1 is the remainder. Remember when we said odd and even, right? So we put 1 here. Then we divide again. 2 divided by 19, it's 9. Remainder 1. 2 divided by 4. No, 2 divided by 9. We get 4. Remainder, is there remainder? Yes. Remainder is 1. Okay. 2 divided by 4, it's 2. Any remainder? No, there's no remainder. Put the 0 there. 2 divided by 2 is 1. Is there any remainder? No, we put 0 there. So this is also another important part. 2 divided by 1, 2 cannot be divided by 1. So we say we put 0 there. Then remember there was a remainder here, right? Now that remainder, we bring it here. Okay. So it's 1. Remember the third step, which I told you is very important. This is the last step, right? So we start from the last. We read it like this, from this last going up. Don't make a mistake of reading from the top going, because you'll get a very different answer. So we start from the last step to the first step. So in our case here, we got 1 0 0 1 1 1 0 0. Okay, yes. So for the first time, you might be a little bit confused of is my answer really correct? So that's why since we already know how to convert from binary to binary, and since we know the binary, we can do a quick conversion also, just to confirm that our answer is correct. So what do? We put our column table 1 2 4 8 16 to 128. Then we put the number 0 0 1 1 1 0 0 1. Yes. Then we calculate the ones again. And yes, see, very easy. Now we get 128 plus 16 plus 8 plus 4. We get 156. Is the 156 the answer we were told to do? Yes. So from this, we already see, then it's correct. Now, next, let's convert hexadecimal to binary. Hexadecimal to binary. First thing also, I told you, let's read the steps. So it tells us to separate the value into its individual elements. Okay. Then convert each element from decimal to binary. So we'll convert from decimal to binary. Okay. Then the next is we will combine the resulting binary numbers into one string. Okay, combine the resulting binary numbers into one string. So For us to understand the steps well, we will do an example. So the example is we've been told to convert hexadecimal number, which is 64FA, into binary. So the first step, we've been told to separate the value into its individual elements. So we've separated like this, 64FA. That one we already finished. The number 2, we've been told convert each element from decimal to binary. From decimal to binary. So for us to convert this, we also have to convert them into binary. So what we are given is we have been given hexa, right? So 64FA. Now 6 in hexadecimal is 6 in binary. Good. 4 in hexadecimal is 4 in binary. Good. F in hexadecimal is 15. Remember, we said 10 is 8, then 15 is F. That's for hexadecimal. So we put 15 here. Then A we said is 10. Put 10 there. Okay. Then remember, now we want to convert it back to binary. So for 6, yes, for this 4-bit, it's very easy to get them to convert them into binary. Okay. So for example, this 6, we know this will be 2. No, this will be 1, 2, 4, right? So 4 plus 2, 6. 4, it will be easy. But now remember, 6 will be 1, 1, 0, right? Yes. But since we want them in 4, remember we need to put them into 4-bit. We add a 0. We add a 0 here, the leftmost. Okay. So for example, even if you get later, you'll get even it's 1, 1, we'll have to add 2 zeros. But for our case here, we'll just add 1 0 to make it 4. The same we go with 4, which is 0, 1, 0, 0. Then for 15 is 1, 1, 1, 1. Then for 10 is 10, 10. We just use we use this here. If you want, you can also divide the one for remainder to be sure of your answer. Okay. But I'm just trying to give you a shortcut to just, yeah. But remember, in your exams, you'll be asked to show the workings. So you can get the workings like that. So for this, we get 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 1, 0, 1, 0. Okay. Then the last step here, we've been told we need to combine. So we combine all of them. So after combining them, we find that's our answer. So 64FA, our hexadecimal, is 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, 1, 0, 1, 0 in binary. That's how we convert. Now, the next one, we are supposed now to convert from binary to hexadecimal. So with this one, we will start with, we group the binary digits into sets of 4. Okay, sets of 4 now we know. Starting from the right. Okay, good point. Then pad the leftmost group with leading zeros if it has fewer than 4 digits. Okay, we practiced it in the last one. Okay, we'll see also how we'll practice it here. Then the third one is convert each 4-bit group into its corresponding hexadecimal digit. Then the last one is combine the hexadecimal digit to form the result. Okay, now let's apply our steps. Let's convert the binary 11011011011 to hexadecimal. Okay, now let's do it. So the first step, we've been told to we group them into 4 starting from the right. So this is our right? So we start, okay. Then you see, then the next you are told part the left. You see this one is not 4, it's 3. Then we go to the next step. We're told part the leftmost group with leading zeros if it has fewer than 4 digits. So yes, step 2, since the leftmost has 3, we add 0. We already added here, right? So it's 0, 1, 1, 0. Okay, we've already added our 0. So the third one is convert each 4-bit group into its corresponding hexadecimal digit. So before we do this, we have to also convert it to binary. Okay, so we group them like this. The way we group them like this, we create our column. Yes. So in binary we get this. We've already divided them, right, into 4 in a set of 4. Okay. So 0, 1, 1, 0. For this we just do our 1, 2, 4. Right, 6. So we know this one is 6. Use the same 1, 2, 4, 8. So 8, 4, 1. That's 13. This one we do 1, 2, 4, 6 plus 1, 7. Okay, so we do 6, 13, 7. So this is the value of it in binary. But remember, we need to convert it to hexa. So D in binary is 6 in binary is 6 in hexa. 13 in binary is D in hexa. Then 7 is 7. So we combine all and we get 6D7. So as for hexa, we already agreed they are 16, right? So 0 to 9, then from 10 is A, so it goes A up to 15. Remember, it's in base 16, right? So 15 is F. So that's how we do it. Okay. Now we'll go to the second last one. So this one we have to use one of the methods we used for this conversion. This one. So we'll convert hexadecimal to binary. So the first step, we're going to convert the given value to binary. Then take the binary result and convert it into binary equivalent. Okay. Now let's apply it. We've been given A3. Okay. Given A3. So the first is convert the given value to binary. Okay. So we've been given A. So A, we all know it's 10. Okay. Now 10, if we want to, we need to convert this 10 to binary. So we use the we divide by 2 till we get it. So with this one, we just know it to be 10. Okay. So here you have to also confirm 1, 2, 4, 8. Actually, there's a shortcut of doing it, but that one we will learn later. So just 8 plus 2, 10, right? So yeah. So 10, 10. Then 3, yeah, it's 1, 1. So remember, it has to be 4-bit. That's why we add 0, 0, 1, 1. Then the result, once we combine, we get it's 1, 0, 1, 0, 0, 0, 1, 1. Okay, so that's A3 already. Then the next step we're being told is take the binary result and convert it into binary. Now Once there's this convert, we need to use our table again. Yes. What do we start with? 124 to 128. Okay. Then we bring the 10. We'll put the binary digits into the column. So 11000101. Then remember this. Yeah. Then so that's 128 plus 32 plus 2 plus 1. It's 163. So that's how we convert from hexa to binary. I hope that is very clear. On the next one, actually this is the last one, we want to convert from binary to hexadecimal. Binary to hexadecimal. So our first step is convert the value to binary. Then group the binary digits into sets of 4, and convert those groups directly to hexadecimal. Okay, and we've been given 45 as our example, so we need to start the steps to see if indeed we'll get. So we have been told to convert the value, then convert the value to binary. So this is binary. We have been told to convert to binary. Now, this one, remember the formula we used. You need to convert to binary, the one for division. 2 divided by 45 is 22, remainder 1. 2 divided by 22 is 11, remainder 0. 2 divided by 5, no, 2 divided by 11 is 5, remainder is 1. 2 divided by 5 goes 2, remainder is 1. 2 divided by 2 is 1, remainder is 0. Okay, then remember this important part. 2 divided by 1, it will never be divisible, right? It will never divide, so we say it goes there 0 times, which is true. The remainder is 1. That 1, we bring it here. Then remember the rule we said, you start from the last step going to first step. Or rather, we can say you start from bottom going up. So what do? We get this is our binary digit, okay? But that's not the final answer because we need to now convert this now to hexadecimal, okay? So how to then group the binary digits into sets of 4 and convert those groups directly to hexadecimal. So we divide them into groups of 4. Remember, we start from right. Yes, we already got 1101. Then there was 10, and I said if, as we discussed, if they are less, if this is only 2, right, we add extra zeros to make it 4 digit, 4 bit rather. Now this one is 2 because if you use 1, 2, 4, 8, so it's only 2. So 2 in binary is 2 in hexa. Then 1101. This is 1, 2, 4, 8. We do this, we get 13. And 13 in hexa is D. Okay? Yes. I think with that, we've already covered the number system and the number conversions, all of them. So in the next topic, we're going to, in the next part, we're going to discuss binary calculations and uses of hexadecimal. Until then, have a good day and have a good computer science lesson. Thank you.